indicate whether the compounds in each set are constitutional isomers? Well, constitutional isomers are molecules that have the same formula but different connection. So let's go ahead and start with A to see what is the formula for the left and the right compound. On the left, we see that we have 2 carbons, C2. We have 6 hydrogens, 3 plus 2 plus 1, 6 hydrogens. And we have 1 oxygen. And let's look at the second formula, 2 carbons. We also have 6 hydrogens and 1 oxygen. These 2 compounds indeed have the same molecular formula. Do they have the same connection? Well, you can see on the left we have an OH group at the end, and on the right we have an oxygen in between the 2 carbons. Therefore, connection is different. Thus, these 2 compounds are constitutional isomers, and choice A is yes. Let's go ahead and look at choice B. In choice B, we have 3 carbons, C3. We have 6 hydrogens, again, and we have 1 oxygen. And then on the right, we have 3 carbons again. We have 6 hydrogens, and we have 1 oxygen. Okay, in choice B, again, we have the same molecular formula. Looking at the connection, we see that on the left side, double bond O is in the middle of on the second carbon, in the middle of the molecule, while on the right side, the double bond O is at the end. Actually, the left one is called the ketone, and the right molecule is called an aldehyde. Even though they have the same molecular formula, they clearly have a different connection because of the location of the double bond O, and therefore these are constitutional isomers. Yes. Let's look at choice C. We have on the left 3 carbons, we have 6 hydrogens, and we have 2 oxygens. Sorry if it's not clear. Here we have 3 carbons again. We have 3 plus 2, 5, plus 1, 6, hydrogens again, and 2 oxygens again. And so both left and right molecules have the same molecular formula indeed. Now, are they the same molecule? Well, on the right we see this group COOH, which is the carboxylic group. On the left side we do not see the hydrogen next to the O. The group is in the middle of the molecule, which is the ester, and therefore, even though the 2 molecules have the same formula, they definitely have different connections, and they are constitutional isomers as well. Alright, so far we've had all constitutional isomers. Let's see if there is an answer choice that has no constitutional isomers. Let's look at D. In D, I have 1, 2, 3, 4 carbons. And let's see, I have 3, 4, 5, 6, 7, plus 3, 10 hydrogens. And I have 1 oxygen. And let's look at the right side. I have 1, 2, 3, 4 carbons. I have 3 plus 2, 5. 5 plus 3, 8. I have 8 hydrogens, and I have 1 oxygen. Let's double make sure. 3 plus 2 is 5. 5 plus 3 is 8. Okay, we can clearly see that the left side and the right side, the molecules do not have the same number of hydrogens. Therefore, they do not have the same molecular formula, and they cannot be constitutional isomers. So we're going to say no here. Let's move to choice E. If you're not familiar with the line structure, every time you see a vertex, that's a carbon. So this is a cyclopentane. There are 5 carbons in here, and then every carbon wants to have 4 bonds. Since we see in the structure that it has only 2 bonds, there are 2 hydrogens on every carbon that were not shown to us. We will go ahead and show them so our counting will be easier. And then we will go ahead and figure out the molecular formula. Okay, we have 5 carbons on the left and each of the carbons has 2 hydrogens, which makes the formula C5H10. And let's look on the right. We have 1, 2, 3, 4, 5 carbons again. And then we have 3 plus 2, 5, 7, 9, 12. We have 12 hydrogens here. Since the molecular formulas are not the same, these compounds are not constitutional isomers. These are not. And let's look at choice F. We have already seen this molecule before. We said that its formula is C5H10. And let's do the molecule on the right. We have 1, 2, 3, 4, 5 carbons, C5. And let's count how many hydrogens. 2 plus 1 is 3, plus 2 is 5, 6, 7, 10 hydrogens here. So our formulas are indeed the same. These two compounds have the same molecular formulas. Now, do they have the same connection? Well, on the left side we have a ring, and on the right side we have a double bond. Definitely the connection is not the same, and therefore these are constitutional isomers. Please subscribe to my channel for more organic chemistry videos, and I will see you next time. Have a good day.